start determinant note 1. In this determinant note 1 we have 10 to 15 sums based on some important sums and some basic sums. So first we are going to solve some basic sums, and based on these basic sums we will try to solve the important higher level sums. So let's follow the first sum of today. Sum number 1, which is given determinant a plus x y z, x a plus y z, then we have x y a plus z. Clear? So this is our sum. So first we see that if we add column 1 with column 2 with column 3, then we get a plus x plus y plus z, this factor common. So what we operate is C1 operating C1 plus C2 plus C3. So we operate C1 operating C1 plus C2 plus C3. Means we are going to add C1 with C2 plus C3. So what we get in first column, because changes will be there in the first column as we have only changed the first column. So it is a plus x plus y plus z. This one also a plus x plus y plus z, and this is also a plus x plus y plus z. Now this one is y, no change, as only C1 will be changed. A plus y, y. This is z, z, a plus z. So this is equal to a plus x plus y plus z all common from first column. As in determinant, we can take column either from any row or from any column. We have a plus x plus y plus z in first column, so we have taken a plus x plus y plus z common from column 1. So we are left with 1 1 1. Then we have y, a plus y, y, z, z, a plus z. Now we have to form 1 0 0 form to delete this first row and first column. So what we would do is a plus x plus y plus z. So this will become 1 0 0. This is y, this is z. So a plus y minus y, this is a, z minus z 0, y minus y 0, and this minus this is a. So what we have operated? We have operated R2 operating R2 minus R1 and R3 operating R3 minus R1. We can perform R3 minus R2 also. So what we get, this determinant gets cancelled. So we get a square, this determinant is a square minus 0. So a square minus 0 into a plus x plus y plus z. So that means the value becomes a square into a plus x plus y plus z. So this is our answer. Now we will solve the second sum of today, which is very important sum, and the topic is very important for board exam and school exams. The second sum is given, sum number 2, determinant x plus 4, x, x. Then we have x, x plus 4x. In diagonal we have x, and non-diagonal elements all are x, and diagonal elements we have x plus 4. So just we have to find the pattern. That means the operation we will use will give us some exact pattern. So pattern is that if we add R1 operating R1 plus R2 plus R3, we get 3x plus 4. But if we operate C1 operating C1 plus C2 plus C3, we also get 3x plus 4. So we can choose any of the operation, that is adding R1 with R2 plus R3, otherwise C1 with C2 plus C3. So we choose row operation. We can easily choose also the column operation. There is nothing wrong. So R1 operating R1 plus R2 plus R3. This operation we have chosen. So what we get, first becomes 3x plus 4, first row. All the elements will be 3x plus 4. Then we have x, x plus 4, x, 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 x plus 4. So we get 3x plus 4 out of the determinant as common from the first row. So we are left with 1, 1, 1. Then we have x plus 4, x plus 4. Now we have to make this one 0 and make this one also 0. Since these one are in first row, so we have to operate column operation to make it 0. So we do C2 operating C2 minus C1 and C3 operating C3 minus C1. We can choose C3 operating C3 minus C2 also. There is no problem. So this is equal to 3x plus 4. 3x plus 4. Then determinant we have 1. This will be 0, 0. This is x, no change because C1 is not changed. C2 and C3 will change. So what will be C2? C2 operating C2 minus C1. So this will be 4 and this will be x minus x0. Now this one C3 operating C3 minus C1. So 0 x plus 4 minus x, this will be 4. Now 1, 0, 0, the determinant gets cancelled. We have 16 minus 0. We have 16 minus 0 into 3x plus 4. And this means the result equals with 16 into 3x plus 4. So this is our answer. So this type of questions are always given in 2 marks question, where by adding the rows or columns we get some row or column becomes identical. That is, all the elements in the row are same. So in that case we can take out the common element and the form will be either 1, 1, 1 in row or 1, 1, 1 in column. If we get 1, 1, 1 in row or column, we have to make it 1, 0, 0. So that we can delete the row and column. We get a 2 by 2 easy determinant to expand. Next we choose the third sum. The sum is determinant y squared z squared yz y plus z z square x square zx z plus x. Then we have x square y square xy x plus y. This determinant we have to show equal with 0. All these are 2 marks questions as the number of steps are very few. So what we do, we observe that in the second column, see the second column. In second column we have yz. So we have to make it xyz. Second element is zx, so you have to make it xyz. Third element also xy, but make it xyz. So what is short? X is short here, y is short here, and z is short here. So we multiply the second column by xyz. So we have to adjust by 1 by xyz. So we are going to multiply this first row by x because we cannot multiply single element in column. If you want to multiply this element by x, we have to multiply the whole first row, the total first row by x, second row by y, third row by z. So what we get, xy squared z square, then we have xyz, this is x into y plus z. This is y, z square x square, xyz, y into z plus x. And this is z x square y square xyz z into x plus y. Okay, so now we see that we can take xyz common from this second column, and we can take we can take common xyz from the first column also. So we are going to take xyz from second column and xyz from first column also. So we have 1 by xyz. This is xyz whole square. There are 2 xyz, we have taken common, one from this and one from this. So we are left with xyz, we have taken common, so there will be no x. So we yz, zx, xy. This one will be 1, 1, 1. And this is x, we have taken common from this. So this is xy plus xz, and this is yz plus yx, and this is zx plus zy. We have taken xyz from column 2 and column 1, so there is no change in column 3. Okay, so now this we cancel with this, so we are at xyz. Now this 1, 1, 1, this 1, 1, 1, either we have to shift to the third row or we have to shift to the first row, because we are going to make it 1, 0, 0. This 1, 0, 0 is required either in the third column or in the first column. It cannot be in the second column. In that case, we cannot delete the determinant. So since we are going to shift the second column to the first column, so we have to adjust by adding a minus sign. So we are giving a minus sign here, because this 1, 1, 1 in the second column will be shifted to first column. That is second column and first column will be interchanged. So we are get 1 1 1. Now we have this is yz, this is zx, and this is xy, and this is xy plus xz, this is zy plus xy, and this is zx plus zy. Okay, so now we have to erase our portion. Now we have to erase this portion to continue the sum. So after this we have now we continue the sum. So now we have to make it 1 0 0. So this is equal to minus xyz determinant, it will become 1 0 0. That means we have operated R2 operating R2 minus R1, and R3 operating R3 minus R2. We can do R3 minus R1 also. So this is yz and this is xy plus xz. Now zx minus yz. No change, zx minus yz. Now zy plus xy minus xy. So xy both are positive. We are subtracting. So xy xyz cancel out. So we get yz minus zx. Yz minus zx. Now this one. R3 operating R3 minus R2, so xy minus, so this is xy minus xz, and this one zy gets cancelled out, so we get zx minus xy, zx minus xy. So in 1 0 0 this determinant gets cancelled out, so we get minus xyz determinant, zx minus yz, yz minus zx, this one xy minus xz, and this is zx minus xy. Now we will use the minus sign. We will multiply either second column or either first column or the second column by minus 1. So which is the first column? So we are going to multiply this first column by minus 1. So zx minus yz, this will become yz minus zx, as we are multiplying by minus 1. This one will become xz minus xy, and this one is yz minus zx, and this one is xy minus xz. Now we can see these two columns are identical. So the value of the determinant becomes this into 0 equals 0. Reason is C1 identical C2. As a determinant, if any two rows or columns are identical, the value of the determinant becomes 0. Applying that property, the result becomes 0. So this was our third sum today. Now let's proceed to very important sum. The next sum is very important for school exam as well as board exam. Very important sum. Sum is determinant, sum number 4, y plus z, z, y, then we have z, z plus x, x, then we have y, x, x plus y, and this determinant we have to prove 4xy, z. This is very important determinant for any exam, school exam or board exams. So what we have to do, we can see that y plus z is here and y and z are here and there also. So if we add these two rows, that is R2 and R3, and we subtract from R1, we get this element 0. So we choose this process. So R1 operating R1 minus R2 plus R3. That is R2 and R3 will be added and subtracted from R1. So we get this is equal to, so y plus z minus y, this becomes 0. Now this one, z minus z cancel, minus x, so it becomes minus 2x. Y minus y cancel, minus x, it becomes minus 2x. This is z, this is y, this is z plus x, this is x, and this is x plus y. As we have chosen only one operation, R1 operating R1 minus R2 plus R3. So only R1 will be changed. That is R1 will be subtracted from R2, R2 plus R3 will be subtracted from R1. Now we can see minus 2x can be taken common, so minus 2x will be taken common, so we get 0, 1, 1. This is z, z plus x, x, y, x plus y. Now you have to make it this 1 0, because already this one is 0. So if we can make this is 0, then we can delete this determinant. So this is minus 2x, determinant 0. So this is 0. That is, we have chosen the operation C2 operating C2 minus C3, because 1 minus 1 can only be 0. Z minus x minus, so this is 0, this is 1. Now this one is no change, so operation we are using is C2 operating C2 minus C3. So this is z, this is y. Now this one z plus x minus x, this is z, and x minus x plus y, this is minus y, and there is no change, x plus y. So 0, 0, 1, this is cancel. So what we get this is equal to minus 2x, this is a minus yz, so it becomes minus 2yz into minus 2x. The result becomes equal with 4xyz. This one we have to prove it, 4xyz. It's very important sum for school exam and board exam. So many times it is given in school exams and board exams. Now let's proceed to the next sum. The next sum is determinant a square plus 2a plus 1, 2a plus 1, a plus 2, 1, 3, 3, 1. This one we have to prove. This is equal to a minus 1 whole cube. This is also very important sum. You can put star. So in this sum, whenever we get a sum, first we have to see the sum very closely. That is how we can start. The first step is very important. In each and every sum, your first step will decide you will get the answer correctly or not. So in this sum, we have 1, 1, 1 here. See, 1, 1, 1. Whenever we get 1, 1, 1, we try to make it 1, 0, 0, because this gives a very easy way to prove the result. So what we choose R2 operating R2 minus R1, and R3 operating R3 minus R2. Here we choose R3 minus R2 specially because R3 minus R2 will give a very easy result. We can also choose R3 minus R1, but in R1 we have quadratic. There is a quadratic expression in A, so we ignore R1, we prefer R2. So this is equal to determinant. So R1 is no change, so we copy R1, a square plus 2a, 2a plus 1, 1. Now 2a plus 1, this is subtracted from R1. So 2a to a cancel, so we get a square minus 1. Sorry, this is 1 minus a square because we are subtracting R2 from R1, not R1 from R2. So 2a plus 1 minus 2a to a cancel, 1 minus a square. Now this is a plus 2, so this is 1 minus a, subtracting, and this is 0. This one will be 0, this minus this is 1 minus a, and this minus this, it is 2 minus 2a. So what we see 1, 0, 0 we have got, so this determinant gets cancelled out. Now 1 minus a square, factorizing we have 1. So factorizing we have 1 minus a from R1 and 1 minus a from R2, common. So we have 1 minus a into 1 minus a, that is 1 minus a whole square common. So 1 minus a divided, 1 minus a square divided by 1 minus a, we have 1 plus a here. And this is 1, this is 2, this is 1. We have taken 2, 1 minus a common, 1 from R1, 1 from R2. So we can say 1 from C1, 1 from C2. So we get 1 minus a whole square, and this is 1 plus a minus 2. Now 1 minus a whole square and a minus 1 whole square are same, so we can write as a minus 1 whole square, and this is a minus 1. So we get a minus 1 whole cube.